All right, this one says we have a two-dimensional figure and a vertical line shown. The figure is rotated about the vertical line. Which object could be the result of the rotation? So when I rotate this, I want to think about that this would make a circle around here because I'm spinning it, right? So I can see that the top of this would be a circle. This is a solid line. So as I rotate like this, it's going to be filled in completely as I rotate. There's no hole, so that cannot be the case. Okay. Now the difference between these, they all have a circle at the top. This one's rounded at the bottom, this one comes to a point, and this one has a circle at the bottom. This right here is the shape I'm looking for the side of my solid. This goes straight up and down. That's wrong. These two both slant. This one comes to a point while this one is curved. This is curved. So this is going to be A. Okay, number 17. Which figure shows the steps leading to the construction of a perpendicular bisector? When we have a perpendicular bisector, we need, this is a right angle, and this is cuts in half. Okay, so we're looking for something that is cutting a segment in half. When I look here, this is cutting an angle in half. Okay, I don't know what this is doing. This has nothing to connect to, so I'm not really sure what that is. This is going from the side over here. I guess this looks like it might be cutting this piece in half, but it's not cutting this segment in half. And here, if I were to connect these, it's cutting QR in half. Okay, C is the correct choice for this one. When you make a perpendicular bisector, you want arcs coming from the ends. So this arc is coming from R. This arc would be if I flipped it around and came from Q. That's your perpendicular bisector. There's no other way to do this than to look at your construction steps. Okay, number 18. 18 is another rotation question. Okay, so very similar to the last one that we talked about with number 16. My vertical line is here. If I were to rotate this around, I'd make a circle like this. Right here, I'd also have another circle because I have a little gap there. So I'm looking for something that has a hole in it. It's going to look like a donut on the top. There's no hole on this one and no hole on this one. These two have holes. This side is like a C shape, so I'm looking for the figure that has a C on the side. This has like a less than sign. This has a C. So this is going to be choice D. Okay. Number 19 says triangle M has a base length of 18 and a height of 12 inches. Triangle N is congruent to triangle M. What is the area in square inches of triangle N? So I'm looking for area of a triangle. When I look on my reference sheet, there is no area of a triangle. Okay, what I need to think about is that when I have a rectangle or a square, if I cut it in half, I get a triangle, right? So it's half of a parallelogram. So the area of a triangle is half of the base times the height. That formula is not given to you. You have to know it. Okay, so it tells me my base length is 18 and my height is 12. So I'm going to do 1/2 of 18 times 12. And I'm just plugging that into my calculator. And honestly, you can use whichever calculator you want. If you want to do the fraction on your handheld calculator, right, you put in 1/2 with the fraction key, and you do times 18, and you do times 12, and then hit equals, and we get 108. That works perfectly fine. You can also use your EOC calculator. you use your EOC calculator, your fractions, the XY button down here. So I have 1/2, and then I do 18 times 12, and I get 108. Both calculators do the same thing, doesn't matter. Okay, then number 20. Number 20, we have the equation of a circle. Okay, for the equation of a circle, we have to remember that we change the sign of whatever's inside here for our center point. So if this is a minus sign, then for our center, it's going to be a positive 1. If this is a plus sign, for our center, we're going to have a -4. You always have to change the sign. Okay, so I'm looking on my pictures for a center of +1, -4. I see a center here that is correct. This center's wrong, this center's wrong, this center's wrong. So for this particular problem, I could get the question right just based off the center. You might have a problem where you have to use the radius because they might have 2 centers that are correct. Remember that your equation of a circle has the radius squared here. So if I want the radius, I have to do the square root of whatever that value is on the right side. So I have to take the square root of that to get that my radius is 3.5. So then I'd be looking on my graph to see which one goes out 3.5 units. And this one works. But like I said, you might have a problem on your test where you have 2 centers that are correct and you have to pick the right radius. So just remember, take the square root of the number that's on the right. Number 21. Oh, actually, we're going to stop right there and I'm going to start the next video.